Okay, for topic three, we're gonna look at the actual addition property of equality. So that was kind of the sort of the title of this section. It was solving equations and then the addition property. So this is it. We're gonna look at our first step to solving equations, okay? So these are gonna be like really simple one step, and then I kind of throw in a couple of two-step equations, but these are gonna be pretty straightforward, all right? So what we need to do is just kind of understand and practice the addition property of equality. So first of all, we have not a definition, but we have a fact, okay? So a fact. When given an equation, the equal sign indicates that the equation is balanced, meaning the left side equals the right side. So we talked about this in the previous example. You have to always maintain balance, okay? So that's our goal here, to maintain balance in the equation while solving. So while we're taking those steps to isolate the variable, whatever we do to one side, we must mimic and do the same thing to the other side. We have to maintain that balance. That's super, super important, okay? And the addition property of equality is one step that allows us to maintain balance. It helps us maintain balance. So it basically says the property allows us to move terms from one side of the equation to the other by performing the same addition or subtraction to both sides of the equation. So we've got kind of symbols here. It says, let A, B, and C be real numbers, okay? If A equals B, then A plus C is going to equal B plus C. So that just means if you add something to both sides of the equation, it's still going to be balanced. The left is still going to equal the right. And the same thing is true for subtraction. So if A is equal to B, then A minus C is still going to equal B minus C. So again, we can add stuff to both sides of the equation, or we can subtract stuff from both sides of the equation. And that's really, really important because that's going to be a pivotal part of the solving process. Okay? So let's do some really simple examples. Okay? So example three says, apply the addition property of equality to solve each equation. Check your solution. Okay, now remember, the heart and soul of solving equations is to isolate the variable, and the way we isolate the variable is we undo what has happened to that variable. Okay, so for part A, we have x plus 5 equals 9. So I can see here that my variable has a 5 added to it. So how in math do we undo addition? Well, in math, we undo addition with subtracting. So if I wanted to get rid of this positive 5, I could subtract 5. But in order to maintain balance to the equation, if I subtract 5 on the left, I must subtract 5 on the right. So then what happens? Well, we get really lazy in math, especially algebra, and we're like, oh, things cancel. They just disappear. No, they don't just disappear. Things don't just poof disappear in math. When we say things cancel, they either cancel to become a 0 or they cancel to become a 1. So looking at this example right here, what we really have is 5, positive 5 minus 5. So what is 5 minus 5? Well, 5 minus 5 is 0, and then x plus 0 is just x. So we got our x alone. Okay, now we have to simplify the right-hand side. So we get 9 minus 5. Well, that would be 4. So essentially, the value for x that would make x plus 5 equal to 9 is 4. So let's check our work. So we're going to check to make sure that 4 really does satisfy this equation. So to do this, we take the original equation, which is x plus 5 equals 9, and we want to sort of evaluate it for x equals 4. So anywhere you see an x, plug in a 4 and see if you get a true statement. So x is really 4 plus 5. Well, what is 4 plus 5? 4 plus 5 is 9. Does 9 equal 9? Yes. So we can say that 4 satisfies the equation. So we can say with a very high level of confidence that 4 is the solution to this equation. Okay, so this is the solution. Now, sometimes, especially when you go higher in math, so not too much at this point in your math career, but if you were to take higher levels of algebra, we would write our answer in what's called set notation, or sometimes you'd see it solution set notation, and that's where you use the curly braces and you put your solution inside the curly braces. Now you don't put the x equals, you just put the whatever x was equal to. So we would say our solution is 4. Okay, so don't be alarmed if you see that like on a worksheet or in your textbook or in your online homework. It just means that's our solution. Okay, let's look at part B. So in part B, we have x minus 11 equals negative 17. So what value for x when we subtract 11 gives us negative 17? Well, a lot of us can kind of like look into the crystal ball and we can see what the solution is here, but we want to know how to do this algebraically. Like what steps do we need to take? Well, we need to undo what has happened to the variable. In this case, we took the variable and we subtracted 11. How do we mathematically undo subtraction? Well, with addition. So I could add 11, but if I add it to the left, I must add it to the right as well. Again, we got to maintain balance here. Okay, so on the left, negative 11 plus 11 is just 0. And then x minus 0 is just x. So we got our x alone, which is great. Now we need to figure out what the right-hand side of this is going to equal. Well, negative 17 plus 11. So we're adding two numbers with different signs. That means we really subtract. So 17 minus 11 is 6, but is it positive or is it negative? Well, in this case, it's going to be negative. So we think our solution is negative 6, but let's check. So we know from the previous example, to check our work, we basically just evaluate in this case, the left-hand side. We evaluate the left-hand side of the equation for negative 6 and see if we get it to equal the right-hand side. So we just rewrite the equation. Anywhere we see an x, we replace it with a negative 6. So we get negative 6 minus 11. Well, negative 6 minus 11, if you absolutely must, you can still use some of the steps that we took when we were in the earlier chapters of this book. So we can rewrite subtraction as addition. Now, you kind of want to start to stray from this. You don't want to have to show work every time you do this. We're hoping that at this point, you're pretty good at doing some of this mental math, like especially with the signs. But this is technically negative 6 plus negative 11. Well, when you add two numbers that have the same sign, you just add them and then keep the sign. So 11 plus 6 is 17, and they're both negative, so it really is negative 17. So this is true, so we can say with confidence our solution is negative 6. And remember, you could see the solution set notation where you have curly brackets with your negative 6 inside. Okay, now the last two examples, it's the same amount of work, except you have decimals and then you have fractions, which the process is the same, but the simplifying might be a little more involved. Okay, so for part C, we have x plus 3.5 equals negative 2.8. So we want to undo what has happened to x. Well, x has had a 3.5 added to it. So we subtract to remove the 3.5. So the opposite of adding 3.5 is subtracting 3.5, and we have to do it to both sides of the equation. Remember, we have to maintain balance, so what we do to the left, we have to do to the right, okay? Now, positive 3.5 minus 3.5, that's just 0. X plus 0 is just x. And then we have negative 2.8 minus 3.5, okay? Now, if you need to, you can rewrite this as addition. So this is negative 2.8 plus negative 3.5. And then if you want to, you can do your side work. When you add two numbers that have the same sign, you literally add, just keep whatever the sign is. And with addition of decimals, you want to line up your decimal points. Okay, so 8 plus 5 is what, 13? So I keep a 3, I carry a 1. I drop my decimal down into my answer. And then 3 plus 2 plus 1 is 6. So we end up with 6, but since both numbers were we end up with 6.3. But since both numbers were negative, we want to make sure this has a negative. So we get negative 6.3. The directions told us to check. So we're going to take this equation. Anywhere we see an x, we're going to plug in a negative 6.3. So we get negative 6.3 plus 3.5. We want to know, does that equal negative 2.8? So let's do some side work again. And you can use your calculator here, but this is a good way to review, okay? So we have negative 6.3 plus 3.5. When you're adding two numbers with different signs, you really subtract. So we want to take 6.3 and subtract 3.5. Well, let's see here. I can't take 5 from 3, but I can borrow. So my 6 becomes a 5, and my 3 becomes a 13. And then 13 minus 5 is 8. Drop down your decimal, and then 5 minus 3 is 2. Now, we started with negative 6.3 plus positive 3.5. We definitely had more negative than we did positive. So this would be negative 2.8, which does, in fact, equal negative 2.8. So we can say with confidence our answer is negative 6.3. And again, we could write it all fancy like this. Okay? Last up for this example, we have x minus 3/4 equals 2/5. Darn those fractions. At some point, embrace them, love them, appreciate them. Okay? Now, what we want to do is get the x alone. The issue here is x has negative 3/4 subtracted from it. So how do we undo subtraction of 3/4? Well, we add it. So we're going to add 3/4 to both sides here. Well, the left is easy. Negative 3/4 plus 3/4, that's just 0. So we get x equals something, okay? So off to the side, what we have is 2/5 plus 3/4. So we're adding two numbers that have different signs, okay? And remember, when you're adding numbers that have different signs, you need a least common denominator. So what's the smallest number 5 and 4 divide into? Well, that would be 20. So we need to rewrite these fractions with equivalent forms that have a denominator of 20, okay? So let's see what we can get here. Let's use blue. So what would I multiply 4 by to get 20? Well, I'd have to multiply it by 5, but if I multiply the denominator, I have to multiply the numerator. I'm really just multiplying by a weird form of 1, okay? Now on 2/5, what would I multiply 5 by to get 20? Well, I'd have to multiply it by 4. And if I multiply the bottom by 4, I have to multiply the top by 4. So again, it's like a weird form of 1. We're not changing the value of 2/5 or 3/4. We're just changing their appearance to make them easier to work with. So let's see, we get 8/20 plus 15/20. So let's see, 15 plus 8. Well, 8 and 5 is 13, carry a 1. So we get 23/20. So my final answer is 23/20. And you can leave it in fraction form like that. You could certainly write it as a mixed number. But generally speaking, when you're just solving like generic equations that don't have like a story behind them, leave your answers as simplified improper fractions, okay? Don't write this as a decimal. Don't write this as a mixed number. Leave it the improper fraction. Just make sure it's reduced, okay? Now, if we wanted to check, we would take 23/20 and subtract 3/4 and hopefully get 2/5. So let's see, we've got 23/20. We want to subtract 3/4, but let me show you that you've already done the work to do this with like the proper denominator. We already know that 3/4 is equal to 15/20. So I'm going to subtract 15/20 here. Whoops, let me switch back to black. So let's see, 23 minus 15. Well, I can't take 5 from 3, so I need to borrow. So my 2 becomes a 1, my 3 becomes a 13. 13 minus 5 is 8, and then 1 minus 1 is just 0, but we don't write the 0. So what we get is 8/20, but we would need to reduce that. So let's see, 8 and 20 are both divisible by 4. So 8 divided by 4 is 2, 20 divided by 4 is 5, and we get 2/5 is equal to 2/5. So it took a little work because fractions, but there we have it. We can say with confidence our solution is 23/20. And again, resist the urge to write this as a decimal or a mixed number. Decimals and mixed numbers certainly have their place in this world, but with generic fractions, we generally leave our answers as just reduced improper fractions in a situation like this. Okay? Now, I do have one more example, and I don't have it as a separate topic, so this is just going to be a slightly longer video. So it says example 4, simplify both sides of the equation and then apply the addition property of equality to solve. So these are a little bit more involved, but that's okay. We're going to try to simplify the left and then simplify the right and see if we can get down to something where we can just use the addition property of equality. Okay? So we're going to combine like terms if we can. We're going to distribute if we need to. Okay, we're going to kind of clean up each side and get it as simplified as possible. So for part A, we have 3x minus 2x plus 5 equals 5 minus 2. Well, on the left, we have 3x minus 2x. We can do that. 3x minus 2x is just 1x, but we don't write the 1, we just write the x. And then we've got that plus 5. And then on the right-hand side, we have 5 minus 2, which is really just 3. So with just a little bit of simplifying on either side of the equal sign, we got this down to something that we can use the addition property of equality with, okay? We want to get this x alone. The issue is the plus 5. So how would I undo addition of 5? Well, I would subtract. And I'm going to do that from both sides of the equation. Okay, so on the left, 5 minus 5 is just 0, which leaves me with just an x. Okay, and then 3 minus 5 is -2. So that would be my solution. If I plugged -2 into the original equation and simplified, I would get a true statement. Okay. Now, part B, same directions. We want to simplify as much as we can and then apply the addition property of equality. So the first thing that I'm just like itching to do is get rid of parentheses. We want to distribute first. So I'm going to take 6 times 3x. So I really just multiply 6 and 3, which is 18. And then I keep the x. And then I want to take 6 times 1. That's just 6. And then we're going to write down the rest of the equation. So I have minus 17x equals 2. So now I have like terms. So I have 18x minus 17x. That equals just 1x. So I would write it as just x. Don't forget your plus 6 and your equals 2. All right. So now I can solve this. So the issue is that x has a 6 added to it. So how would we undo addition of 6? Subtract. So I subtract 6 from each side. 6 minus 6 is just 0. X plus 0 is just x. And 2 minus 6 is -4. So even though this equation here and this equation here, they looked really complicated, by doing just a little bit of combining like terms and simplifying, we were able to get to something where we could use the property that we know, which is the addition property of equality. Okay, so that's it for the addition property of equality. In the next worksheet, we're going to look at the multiplication property of equality.